I guess I'll start early because the door's closed. So, good morning, everyone. Welcome to my session. I want to talk to you today about how to build IoT solutions using Azure IoT Edge. I'm Edwin van Wijk. I work for Info Support, and I work there as a principal architect, so I help lots of our customers with their architecture, software architecture. And I do lots of stuff with Azure. I don't actually do a lot for my customers with IoT, so this is more my hobby space stuff. But I thought it was really cool, and I wanted to do a session about that. I'm also a Microsoft MVP, and I don't know if you know about the MVP program, but next Saturday we will be flying to the States for the MVP Summit. That's a really cool week at the headquarters of Microsoft in Redmond, so I'm really looking forward to that. So I'm happy, and I hope you guys will be happy also after this session. If you have any questions, just ask in between. So just to dive right in, why do we need an IoT on the edge? The edge is what Microsoft calls all these devices that are out there, so computers, but also, as you can see here, all kinds of sensors, cameras, and stuff like that. And the traditional IoT was that you have some device somewhere, and this device sends all its data to the cloud, and you do all processing in the cloud. And this is cool because we have lots of processing power in the cloud, and it's all awesome. But what we often see is that not all these devices are always connected, or not all data needs to go to the cloud. And that is why something called IoT Edge, or IoT in the Edge, came up, because we have processing power on these devices. Today I'm going to talk about a Raspberry Pi. I have a little short lead on it, but this is just a Raspberry Pi. It's up and running, and it's doing all kinds of IoT stuff right now. But there's lots of processing power on there. So if we could do some processing already on the device and then send the results to the cloud, that gives us lots of advantages. So we have intelligence closer to the devices in the edge, so we can do also real-time stuff. We don't need to go to the cloud for everything, but can react on data that we get in. We need to send less data, which is cool because we don't need all the bandwidth, and we only need to send the data that is important to handle in the cloud. Sometimes you don't even want to have all the data in the cloud, maybe private data or whatever. And like I said, occasionally connected scenarios. So if you're on a cruise ship, then you're not always connected to the internet. And if you have some IoT devices, it would be cool if they can do stuff without being actually connected to the cloud. So Microsoft has a vast array of tools and frameworks and offerings that you can use if you start doing IoT. This is a picture that I stole from the documentation website. So there's lots of stuff out there. So if you start working with IoT, just look at this documentation and pick the right tool or the right framework or the right solution for the thing you want to do. And today we're only going to look at this little part here. So that's a bit to frame where we're at. So Azure IoT Hub and Azure IoT Edge, but there's lots of stuff out there. If you're into security on IoT devices, then you need to look into IoT Sphere. That's also a very cool technology by Microsoft and other hardware vendors, but that's not part of this session. So let's dive in and tell you about what is IoT Hub. Well, IoT Hub is basically the central communications hub in the cloud. This is where all IoT devices send their data, and then from this hub, you can do all kinds of things with this data. Also, you can manage your IoT devices from the hub. And I will show you that in a minute, because I forgot to tell you this is a little bit of introduction, and then I dive into demos and code and Visual Studio Code. Let's get this stuff over with real quickly. You get health monitoring. So if a sensor or some IoT device goes down, you can just react on that. You get telemetry about that in the Edge IoT Hub. And it enables integration with other Azure services. So you can just say, if a message comes into the hub, send it to an Azure Service Bus queue, or send it to a storage device, or whatever. So it's basically, your distribution center in the cloud. And then we have IoT Edge. And IoT Edge is more the runtime, or the ability to run workloads on IoT Edge devices. And I specifically said cloud workloads because there are several workloads that you can run now in the cloud that you can run on an IoT Edge device without any changes. And we will look into that a little bit later. It is cross-platform, so you can run Linux and Windows-based workloads on the Edge. And basically you make use of the resources that you have on your IoT Edge devices. So, like I said, pre-processing or normalizing the data or filtering stuff. Also here, you can manage your IoT Edge devices from the cloud, from the IoT Edge blade in the portal, for instance, or through an API. And it supports these occasionally selected connected scenarios. So if you send a message from your IoT Edge device and you're not connected, it will keep the message. And once you get reconnected to the internet, it will send the message and become eventually consistent. And you can also keep your private data on the edge, just like I said. So without further ado, let me give you a little peek into what this looks like in the Azure Portal. Let me see, where is that at? It's over here. So this is Azure Portal. I created an IoT hub. So this is an IoT hub in the cloud. And here you have the IoT Edge blade. And there you can see that I have now 2 devices up and running, and I will show you later what they're doing. It is one VM in the cloud. This is a Linux VM that runs the IoT Edge runtime, and this Raspberry Pi that's standing over here. They're connected by, this Raspberry Pi is connected through the Wi-Fi of the conference. So bear with me if everything stays up and running, but you know, living on the edge, literally. No pun intended. So, what can you run on an edge device? Like I said, you can do all kinds of stuff. If you had AI or machine learning workloads, or maybe stream analytics jobs that you run in the cloud today, you can package them as an IoT Edge module and run it on an IoT Edge device, which is pretty cool. Azure Functions. If you have an Azure function that runs in the cloud, you can just package it, put it on an IoT Edge device, and run it on the edge. Storage is also, you can just run a Dockerized SQL Server instance on an edge device and store data there, which is pretty convenient. And then, and this is the focus of today, you can write your own code. So you can write modules in the language that you want, and these modules you can deploy onto the edge. And today we're going to look at this one particularly, and I did it in C# because I'm a C# guy, but you can do it in Node.js or Java or whatever makes you happy. So if you want to run workloads on your edge device, I want to introduce some concepts that are important for this session. First of all, we have the edge device. And I put a Raspberry Pi here, but it can be any IoT device. It could be a camera or whatever. And this is where your workloads runs. So that's, I think, pretty clear. It is also convenient that you don't need to run one workload on this device. For instance, for this demo, I'm running 13 modules on one device. And it's fine with that. It's very lightweight stuff. I guess there's now a quota of maximum 20 modules per device. Maybe we can break that quota sometimes, but like I said, running 13 on one device is no problem. This device is uniquely identified by an identity, and it's also secured. So all the connections that the device makes to the cloud through the IoT Edge runtime is all secured. It's all stuff with keys and certificates going back and forth. You don't have to do anything for that. That's baked into the IoT Edge ecosystem. And also very important, this device is represented by a device twin in the cloud. And this is how I can manage this device. So I can change a property in the cloud. It pushes this configuration to your device. It updates, and it goes on. So that's the device. Then we have the runtime. And this is just a runtime, as we know runtimes since a long time. It just is a runtime running on the machine. And it basically has 2 default modules, which are also just basically Azure IoT Edge modules, the agent and the hub. And the agent does all the hard lifting or the heavy lifting of getting modules from the cloud, running in them. So it's basically keeping the desired state of your edge device. And the hub is the communications hub. So messages get sent to the hub, and this will send it to the IoT hub in the cloud. But this runs on the device. And then we have the module. And the module is just a piece of software running on the device within the runtime. And there's an IoT Edge SDK, like I told you, it's for different languages. And the really neat thing here is that these modules are packaged as containers. So this whole IoT Edge thing is completely built around Docker containers, because these are lightweight images that we can just pull down to an edge device and start running it over there. So that's pretty cool. Just like a device has a device twin and has a device identity, also a module has a module identity and a module twin, and that's basically for the same reason. And this is how that works. So I'm now zooming into a module running on a device. This module twin has desired properties. It has reported properties. And the desired properties is what you set in the cloud. So if I change a property, I do it through the IoT hub in the cloud. I say, okay, this property needs to be 100. And it will be pushed to the device, and then the device will report back, okay, now I'm setting this property to 100. So you can see that the reported property comes back. And this is how you can manage the properties of the device. There's also baked into the IoT Edge SDK a way of creating callbacks that get called on your module when you do what is called a direct method. And I will show you this all in the demo, but this is more to tell you what kind of communication you can do with a module in the cloud. And you can do this all from the central, I could do it from the portal, for instance. Either I could have thousands of devices running somewhere out there. I can just pick one based on its identity, set a property, and IoT will make sure that it gets to the device and will be updated. So once I have a module, so I've created a module, I have some code, how do I get it on a device? How does this work? How do deployments work? Well, first of all, I have to create some container registry. This can be Docker Hub or a Microsoft Container Registry, whatever. And then you build your code, and you create basically a Docker image. This Docker image, you push that to your repository, and then you can go to your IoT Hub in the cloud, and you register this device. So you just say, okay, I have a device with this name, and I want to run stuff on it. What you then do is, on the device, you install the Edge runtime. You configure the connection string of the Edge device that you created in the hub. So a unique connection string is created for that device. You configure that, and then this connects into the IoT hub and starts communicating with it. Once you have that done, you deploy a module, and that is done through a deployment manifest, and we will look into that later when we look at the code. This deployment manifest will tell you which modules need to run on the device. And then it will create the device twin, update the configuration. It pushes this configuration to my IoT Edge device. Then the agent comes into play. It pulls the Docker image that was specified in the manifest, pulls it down to the Edge device, and runs the Docker container. And then it can start communicating back and forth with the IoT hub. And the first time that I started with preparing this session, I looked at a conceptual picture. And I thought, wow, this is very complex. This is a lot of stuff. I don't know if I understand what goes on here. Actually, if you start doing it and you follow the documentation that Microsoft created, they have lots of getting started and tutorials. It's pretty easy, and I will show you in a minute. So, is this clear? Because we're going to do this live, and I want you to understand what goes on behind the scenes. If there's anything that's not clear, please ask me. But this is how this works. Okay. So let's look at an application of IoT Edge, and this is all around the case of a shopping mall. So I created a map of a shopping mall. This is one level, and you have all kinds of shops in here. And what I want to do with my solution, I want to make an overview of how many people are in these individual stores. So what I did was, I just put up sensors at the entry of every shop that can detect whether a customer walks into the shop or walks out of the shop. That could be a very simple sensor. And once this sensor detects a customer, it will send an event into the IoT hub, and then I will pick that up and show that on a dashboard. So it's pretty simple, not real complicated, but I thought it was a really nice demo. So what does this look like? I will scoot over now first to the, where is it at? Oh, I had to open two browsers. So this is it. This is just an ASP.NET Core web application that gets all these notifications from the IoT hub, and I will show you in a minute how that works. And every time a customer walks into a shop, it will flash green. If a customer walks out of the shop, it flashes red. And if a store is closed, I can also see that. So these dark dots mean that this is a closed store, and no customers will go in and out of the shop. The graph that you see over here is just every shop has a maximum capacity, and this will indicate how much of this capacity I have used. And the bottom graph just gives me over time how many people are in all the shops in the mall. So this is the total population of customers in the shop at a certain time. This is really simple to do. I just painted a picture. I have an HTML canvas, and I just place these sensors there. And every time I get an event from the IoT Hub, and I can do this. I put some logging in there. Here you can see all kinds of events coming in from my sensors. And if you can see, this is the identity that I talked about. So if you, for instance, VM01, that's a device. Then door sensor X is a certain door sensor module running on the IoT Edge device. And then the sensor after that, that's the physical sensor ID. So that's the number that you see in the picture. Yes? So how does this work? So I'm now going to look at how I built this solution and which components I use to make this all happen. So we have some stuff running on-prem, or just that's the Edge, I should say. And we have the Azure Cloud, the IoT Hub. So first of all, I created an IoT Hub. And like I said, IoT Hub is the central communication hub. It already creates for me, by default, an events endpoint. That's a built-in endpoint, they call it. And this is where all the messages that come in from the IoT Edge device will be stored. And they will be stored for a number of, you can configure that, but it will be stored for some time. So the nice thing is, for instance, if I now stop my dashboard and I wait a couple of minutes and I start it up, I see really quickly all the messages coming in that I did not get because they were stored in this queue. This can also give you some very weird results. So if you start debugging with this, take this into consideration that these messages stay in the hub until you get it from the hub. It's really important. You can also create your own endpoints or send it to, like I said, Azure Service Bus or whatever.
How long do they stay in?
I guess the default is 1 day, but you have a slider. You can configure all that stuff. You can also say a minute.
Removed if you, let's say, subscribe to them, if you pick them out?
Yeah, then they will be removed. If you don't pick them from the queue, then they will be removed after this timeout. Yeah. So I have an IoT Hub, just like I showed you in the portal. I have my IoT Edge device, for instance, this Raspberry Pi that's running here. And I deploy a couple of these Edge runtime modules, which are the door sensors. And every time I put this sensor on there, I configure it because I have, on every device that I deploy, I have door sensor 0 to 12, but they represent a different door sensor ID. This is a bit weird, but I have to configure a sensor ID that can be different than the number of the door sensor because this is just the number of the module on the device. Then I configure the max capacity of the store, and I give it a status, whether or not the store is open or closed. So these are the desired properties that I can configure on this module. And then this starts, when it starts up, it will start sending messages to the IoT Hub. What I did, because I wanted to get these messages into my web dashboard, I thought, okay, there's an Azure service called SignalR service. This is just a service that you can spin up. You can create a hub, send messages to it, and then from all kinds of clients, I can connect to that hub and receive these messages. That is a push model. So I don't have to pull anything, I just create a connection to the hub, and every time a message comes in, a callback is called. In this case, it's in JavaScript. It's just a JavaScript function running in my ASP.NET Core web application. So that's a pretty cool way of distributing these messages. So if I would write, for instance, a mobile device, a mobile client or a mobile app that will connect to the same hub, also this one will get all the events. But then, how do I get these messages from my events queue in the IoT Hub into the SignalR service? Well, there's a really cool thing called Azure Functions. And I will show you in a minute that it's really easy to get messages from your IoT Hub and send it somewhere, in this case, a SignalR service. So that's what happens. This function picks up the message, sends it to the SignalR service. My ASP.NET Core application connects to the SignalR service and receives the messages. Any questions on this? Because I'm now going to dive into the code, and I want this to be clear. Okay. So let's look at some code. Oh yeah, and I have multiple of these devices. So now I have running my Raspberry Pi and one of the VMs in the cloud. And in a minute, I'm going to create another device also in the cloud and then deploy another set of modules onto this device. So this will be the end state. So without further ado, let's leave the slides and go into code, because that's what you guys came for, I hope. So first of all, let me tell you that when I started working with this, I did everything from the Azure Portal, because you can do anything. You can create stuff, you can send messages, you can update properties. All that is done through the portal. But then I started looking at the tutorials that Microsoft created, and there's a real vast array of extensions that you can install in Visual Studio Code that can help you with developing. So for instance, this is one of the extensions, my Azure Hub devices. If I expand this one, this is the Raspberry Pi, I can actually see that these modules are up and running. Well, not all of them. And this is what I was afraid of. This is because the network connection failed, and then it will start restarting modules because it doesn't have a connection. So let's hope that all my demos work. But this is basically a module twin running on my Raspberry Pi. And I can also get, if I right-click on that and say, get me some module info, it will do a call and will get the information from the device. So I can basically stay in Visual Studio Code for everything that I do. Also, there are all kinds of templates and cool stuff. If I, for instance, go to my command window and I say IoT Edge, you can see there's all kinds of stuff. I can create a new IoT Edge solution, and it will create an entire solution for me with all the necessary files, which we will look at in a minute. I can add a new module. I can, connect to a hub because I'm logged into my Azure subscription from Visual Studio Code. You can do all kinds of stuff, and I will show you a couple of them later on. So first, let's look at the code. This is the sensor modules. This is an IoT Hub solution, IoT Edge solution. And this is the structure that it creates. And it has a modules folder. And I won't be looking at all the files, but just the most important ones. And within there is one sensor, or one IoT Edge module, in this case, the door sensor. And I can add another one. I can just right-click and say, add me another IoT Edge module. So it's all doable from Visual Studio Code. This door sensor is a C# implementation of a module, so it just has a program.cs, and I want to look at the code with you, how this works. So this is one of these door modules. It just has a main. Everything is asynchronous, so it's all optimized for performance and stuff. And let's skip to this line, because this is where it becomes interesting. This is something that I call, this is part of the SDK, so you get a couple of classes from the SDK. I can create a module client, and this is how I connect and communicate with the outside world. And I created the method initAsync. If we go to this method, what happens here is I create this client, and I use transport settings. There are several protocols that you can use, and there are several stuff that you can configure. Then I create the client with these settings, and I say open async. And once that happens, I basically have a connection with my IoT Hub. And then I return the client so I can use it in the rest of my program. Sorry for the scrolling. Once I have this client, what I then do is I retrieve the twin for this module through this client. And then I say, get me the desired properties for this module from the cloud, and throw that into the ondesired properties update method. This is a method that I created. It will get the desired properties from the cloud, and it will then set these properties. So one of the things that I do, this is a private property that I created, and this is just a simulation, right? So this is just wait a random interval and then tell me that a customer entered or exits the store. And it has properties like what is the sensor ID, what is the max capacity, and what is the store status. And I just set these properties, and then I'm done. And then I return, okay, everything is well, and then the properties are updated. So when I start this module, this gets called, and then, this is also pretty cool, I register a callback. So every time a property updates, it will call back this method, and the property will be updated. And this is a way to communicate with my IoT Edge module. Like I said, you can also call methods, and this is the way you configure that. So I say set a method handler async. If set customer count, that's the name of the method that I have to specify when I call it, then you have to call on set customer count. And that's a very simple method. It just updates the current customer count of my simulation. So it's not really elaborate functionality what I'm doing here, but it's about the concept of IoT Edge. Once again, if anything is not clear, then please let me know. Then there's some, I do a lot of console write lines, that's for debugging, and then I basically start an endless loop, and that's this one, the message loop async. And what this does is it creates an event, a door notification event, by using the simulation class. It will give me an event, and that's just a DTO, so I will look into this. It has some properties. For instance, what is the sensor ID, what is the module ID? It gives me the max capacity and the customer count. And the reason I do that in every event is if I skip a couple of events and I get the next one, I'm still up to speed on, okay, this is the max capacity and this is the current count, and I can immediately update my graphs. But that's a choice. And we have a notification type, which is the customer entered, the customer exited, or the store is closed. And I have the store status, which is open or closed. So pretty simple stuff. Then I have to learn how to double click in Visual Studio Code to keep it open. Then what I do is I deserialize this message coming in. I just make some JSON, and then I send this event through my IoT hub. So this is all I have to do, and I again use the module client to do that. And then I've sent this event, and that will be picked up, will send to the function, and will be sent to my SignalR hub. So that's all there is to it. That's all the code. And if you strip out all the stuff around, okay, I'm here, and all kind of logging stuff, then it's basically very easy to do this. I was actually surprised by how little code I need to write. You haven't seen me do anything like give me this certificate and do a security handshake and all that kinds of stuff. It's all underwater. It's handled for you by the IoT Edge runtime. So I like that. I will also show you the function that I created, because like I said, it's very easy to create a function like this. It was even more surprising how little code. This is everything that's in it. Oh wow, I have an automatic mouse descent algorithm. You create the function, you give it a function name, in this case, publish door sensor notification, and a function in Azure runs on a trigger. So you have triggers, and there are trigger bindings. And in this case, there's an IoT Hub trigger. And it's just an extension that you can use. This is just a NuGet package. This is basically an event hub, but that is where IoT Hub is built upon. So I will just say, when something gets sent to the default endpoint, the queue in IoT Hub, I have a connection string to this one in my settings. And there's a consumer group, because you can have multiple consumer groups on an event. That's not important for this one. And then I just get an IoT Hub message with the payload of the message. In my case, this will be a door notification event that I just showed you. And then I say I have a SignalR binding. This is an output binding. And it works with a collector. It's an async collector. And that is basically an object that I can put stuff in. And then this binding will make sure that it gets sent to SignalR in this case. There are other bindings for storage or whatever. There are lots of cool bindings out there. And then the only thing I do in the function is I get a JSON representation of the message that comes in. I log some stuff because I like to do that. And then I just add a new SignalR message to this collector. And that's it. All the other stuff of connecting and all the security stuff is handled by the Azure services. So I thought it was pretty cool. And the SignalR service is just a service. So you start it up, you connect to it, and then it will get the messages. Yes? One thing I want to show you, I will now connect to my Raspberry Pi. Let's see if this still works. So I'm now through VNC, and I have a cloud connection. I'm actually logged onto this device running here, and I can show you some stuff. There is if you install the Edge runtime, there's a command line interface. I can, for instance, say IoT Edge list. And here you can see these are the modules running on that device right now. And I see there's also a failed one in there. So there's connectivity is not great, but okay, let's keep our fingers crossed. And I can also say, for instance, IoT Edge, give me the logs for door sensor 3. That's a really, I thought you didn't need to type anymore, but you still have to learn how to type with this stuff. And then you get all kinds of logging. And this is all the write lines that you saw just in the code. It will give me all the messages that are being sent.
Question.
Yes?
Why is it that some modules are failing and some are just working fine?
If I tried this the past couple of weeks, it's if you don't have a connection, it will do retries, and after a certain amount of time, it will just fill the module because it thinks maybe there's something wrong with the module. It has to be just, you have to be just in the right situation that you tried it a couple of times, you don't get a connection, and then it gets restarted.
Does every module have its own dedicated connection towards Azure then?
Yes, yeah. If I, for instance, look over here, and this is handled on a Docker level, so this is the network, you can see there are a couple of local networks, and this is the Docker networking that will pick up the connections and then send it out over the main internet connection. In this case, this is VLAN 0 associated to FutureTech 2019. Don't ask me how this worked technically underwater, but every connection gets created, has its own or every module has its own connection to the cloud, but it reuses the same internet connection.
But you cannot restart the modules via the module string.
Yes, you can. You can just restart it, or you can
restart failing ones, and then
yeah, but I don't need to, because this is what the agent basically does on the machine. So if one fails, it will just say, oh, there's a failed sensor, and it will restart it. So if I now do IoT Edge list, I probably get a different picture. Up 43 minutes. So these failed ones failed 15 seconds ago. So it will try to restart it, and then maybe it will fail again. This is actually the first time I've seen that. The only thing that I've seen before is what it also does. If I had forgotten to wait a certain amount of time after every loop, so it started blasting messages, and then you get a back off. It just says, whoa, wait a minute, you're just spoofing, or you're just doing a DDoS on me. Stop that. And then it will back off and then restart it again. So, but this is basically what the agent does on the device. Yeah. So I could really say, of course, yeah, this is for the demo, to show you what the agent does, but this is just failing because of connectivity. See? So now it's a different story.
how lightweight are the Docker images actually?
Pretty lightweight. Yeah, I don't know how big they are. 166 megabytes. So this is not tiny. This is not something that you can run on a...
Which base image they use?
Stretchy, blah, blah, blah. I don't know.
Is it the Linux-based?
Yeah, this is all Linux-based, yeah. And this is the ARM32 version. So it's all, yeah. Okay. The next thing I want to show you is actually creating a new device in my IoT hub, then connecting the device to the hub, and then deploying the sensors onto that. So in order to do that, I will go to my hub blade here, and I will create an additional device. So I can pick this one, create device, sorry, no, that's the wrong one. Create IoT Edge device, of course. And I give it the name VM02. And I already have a virtual machine running in the cloud. And if you want to play with this, there's a standard image. This is an Ubuntu 16.04 LTS with the IoT Edge runtime already installed. Oh, there's someone at your door. Yeah. I think he's looking for his cat, right? That's the one? So I created a device, but this is only the administration. So I have a device defined in my IoT hub, but it's not actually connected to the device. So what I will do is I will copy the device connection string, because I need to have the connection string. And then I go to my Azure Portal. I go to this device, and I haven't opened any ports into that because it's just running out there. But a cool thing that you can do nowadays on Azure is just run a shell script command on a machine. And if you have the IoT Edge runtime installed, then you can just do /etc/IoT Edge /config edge shell script, then paste in the connection string. Don't look at the secrets, please. And I will run this. And what this will do is we'll just update the configuration of the Edge runtime on the machine. It will restart the runtime, and then it will start connecting to the IoT hub. So let's wait a little minute, because I need to know that this works. So we start staring at this screen together. Ah, there it is. Enable succeeded. So I now have actually coupled this real device, virtual device, but bear with me, and I coupled it to the IoT Edge. So if I go back to the IoT Hub and then to the IoT Edge blade, you will see an additional VM. It's not yet okay, because it's now just starting up. And what will happen, like I said, it will get a configuration once I deployed it, and then it will start pulling Docker images from the cloud. Because also the agent and the hub on the device are also just Docker images. So what I can do now is, if this machine is now created, and now I can go to tell you how this works when I want to deploy some modules on the machine. The really cool thing is that when you want to deploy a module, you have to create what's called a deployment manifest. And this is, for instance, the deployment manifest for AMD 64, so just for the Linux machine. And it has this just a lot of stuff in here. And what you basically say is, I configure a couple of modules, so the Edge agent and the Edge hub. And then I define which additional modules need to be created on the machine, on the device. And like I said, I have door sensor 0, door sensor 1. I have 13 of these door sensors. And what you see here is that I also see what the Docker image is that it needs to pull. On top, and don't copy this secret, this is the Azure container registry that I use to push the images to. So, for instance, if I would now have a new version of this module and I want to make it available, I could just right-click here and say, build and push my IoT Edge solution. It will build the image using Docker, so you have to have Docker on your machine, and it will push it to the cloud. Well, it's already there, so it's really, it doesn't do anything. But this is how easy it is. And then you have this image in your container registry, and then if you have this deployment manifest with the definition, so all the door sensors are in here. And also what's really important is that you have to give it the desired properties. So here you see the desired properties of the hub module. And then for every door sensor, I set the properties that I showed you, the sensor ID, the max capacity, and the store status. And now I can right-click this file and say, create a deployment for a single device. It gives me a list of all the devices it had detected. I give VM02, and now the deployment is succeeded. This does not mean that these modules are actually running on the machine, but I have only told this device to start rolling out these modules. So you can see they're defined here, but they're not running. And if we wait, if we wait long enough, we will see them starting up and sending telemetry. And basically, what I've now done, if you look at the configuration, that is these 13 missing ones. So in a moment, they should be starting telemetry.
What's the use of having an Azure Edge device as a VM? If
Testing.
You have an intelligent edge, so you have all your compute power on your edge device.
Yeah.
I can reckon that, but I don't see the use of having a VM for it.
It's just for testing purposes. Yeah. You can also start the Azure runtime on your machine, just on Windows 10, and then you can run it locally. There's also, you can set up, I can run, for instance, this one, I can run in a simulator. There's also a local simulator. So it's just for testing purposes. I only have one Raspberry Pi, but if I would have 3, then I would run it all on the Raspberry Pi. But you're totally right. In production scenarios, what good is a virtual device? You want it to have it in the edge somewhere in a building. Yeah. Any other questions while we're waiting for the agents of the modules to come up? Oh, wow. There it is. So they're now running here. So I showed you the code. I showed you how to deploy these things into the cloud. And now what is pretty cool, for instance, if I take, you see this store is now closed. Store 1 is closed. And this is reflected in the properties of this thing. So if I go to the Raspberry Pi and I go to door sensor 1, and I look at its module identity twin, I see here the desired properties, and you see that it's closed. So what I could do now is change it here, press save, and it will send the new desired properties to my device, and it will update that. So, but you can also do that from Visual Studio Code. So if I go to my Raspberry Pi, I expand the modules, I go to door sensor 1, I right-click, and I say, edit my module twin. The same thing happens. It gets the current one, and it says closed, I can now say it is open. I save the file. I right-click and I say update module twin. And then I have to be really fast to go back to the dashboard. And then in a moment, when the next event comes in, maybe we have some lag because of the slow connection, then this will be opened and it will be accepting customers. What you can also do is, like I said, you have direct methods. And these direct methods will also just be a message that is sent to the machine. And that also is something that I can do from Visual Studio Code. So let's, for instance, take store, what's a big one? Store 12, for instance, store 12. What I can do now is I go to this one, right-click, and I say invoke module direct method. And then I have to give it a name. Well, the method that I defined was set customer count. So I can say set customer count. I have to give it a payload, which is just a JSON string. And I say customer count equals, let's say 100. I don't know what the max capacity is, but it will always go to max capacity. I enter, and then I get back a 200. So that's done. And then for the store 12, as you can see now, it is completely filled up. So this is how you can do all kinds of cool stuff. You can call methods, you can get telemetry back from the device. You can actually do everything from a dashboard or from your cloud. And as you can see, you can do it from Visual Studio Code. So there are some APIs that you can use, but you can also integrate it into your own software. I could, for instance, say I right-click here, and then I can set it to open or closed. And then through the module client, I could just send it an update of the properties or send it a method. Let me see, back to here. So, wow. Excuse me, oh, that's after that. Yes, no, I'm still back on track. So I have some resources for you. There's lots of documentation about IoT Hub and IoT Edge. IoT Edge is actually open source. You can see all the code and all kinds of cool samples if you go to the GitHub. All the code that I have showed you, including the dashboard and everything, that's up on my GitHub page. So if you go to the bottom one, you can get all the code and start playing with this yourself. There are some more IoT sessions. So after this one, in the same room, there's Eldert. He will do also a session on IoT Hub. And there's also a parallel workshop in the workshop area with Jan Willem and Hans. And you can get hands-on with doing some stuff with some industrial devices. So I think I have a couple of minutes for questions, but I would like to thank you and have a great conference.